When you divide something like 9 by its own square root, you end up with its own square root. 9 divided by the square root of 9 is also the square root of 9. That's what the square root means. If you multiply something by itself, you get, if you multiply something by itself to get a number, that's the square root. So if you divide by that thing, it's going to, like for instance, 9 equals 3 times 3. So if I divide both sides by 3, I get 9 over 3 equals 3. And that's true for anything, like 17 divided by square root of 17 is also square root of 17. If you divide something by something smaller than the square root, its own square root, you get something bigger than the square root of itself. Whereas if you divide by something bigger than the square root, you end up with something less than the square root of that thing. And again, if you divide by exactly the square root, you get the square root. This idea of these three sort of facts about math is going to work into a new algorithm for finding the square root. So suppose I want to know the square root of 10. I start with a guess, which I'll call n1. And I'm going to say 3. I know that square root of 10 is between 3 and 4, so I'll just use 3 as my first guess. You can actually use anything as your first guess, but it's better if you use something close to 10, and I like to use the thing that's smaller than it. Now, to check if it's right, I could do 10 over 3 is equal to 3 1/3. And since 3 1/3 is not the same thing as 3, that means that 3 was not the square root of 10. 3 was smaller than the square root of 10. 3 1/3 is bigger than the square root of 10. And our new guess is going to be the average of the guess from before and 10 over that guess. And I like to simplify this, get common denominators, so get 9 over 3 plus 10 over 3 over 2 is 19 over 3 over 2 is 19 over 3 times 1/2 equals 19 over 6. 19 over 6 is a pretty good approximation for the square root of 10. But we can do better. If we take the most recent sort of approximation, 19 over 6, and if we do 10 over 19 over 6, and take the average of those two, I'll get an even better approximation. It turns out that 19 over 6 is a little bit bigger than the square root of 10, and 10 over 19 over 6 is a little smaller than the square root of 10, so the average is going to be closer to it. I'm going to simplify this fraction first. I'll change this. 10 over 19 over 6 is the same thing as 10 times 6 over 19, which is 19 over 6 plus 60 over 19 over 2. The common denominator is going to be 19 times 6, which is 114. And this becomes 19 times 9, and 6 times 60, that's with common denominators. This ends up becoming 721 over 114 over 2, which is 721 over 114 times 1/2, which is 721 over 228. That is very close to the square root of 10, which is 3. This one's 3.16228, and the actual square root of 10 is 3.162277. So very good. And if you have the heart for it, you can do this one more time. So we take our last guess, 721 over 228, do 10 over that. By the way, this 10, if I was finding the square root of something else That's something else would be on top there. Take the average, and I'll just skip to the answer. 1039681 over 3287776. So that's actually 3.162277766, which is correct to all those decimal places. In general, we're trying to get the square root of a, and we could say that n2 is, n1 could be anything. n2 is n1 plus a over n1 over 2. n3 is n2 plus a over n2 over 2. n4 is n3 plus a over n3 over 2, and that process goes on forever.